Hello, wonderful friends. Today, me, Nicholas Winston Ong from Erlangga University Faculty of Veterinary Medicine Semester 2 is going to explain about one organ from the endocrine system and one organ from the integumentary system. Let's get right into it. So for the endocrine organ, I've chosen the thyroid gland. And as for the integumentary system, its representative will be the skin of the fish. The thyroid gland is one of the few endocrine glands inside the body. The thyroid gland is found in the upper portion of the trachea near the junction between the head and the neck. So its location will be right around here. Under histological slide preparation, the thyroid gland may either be in its active form or in its hypoactive form. In its active form, or it is currently producing hormones, the epithelium inside the thyroid gland will be simple cuboidal epithelium or simple columnar epithelium in its low version. While in its hypoactive form, the epithelium in the thyroid gland will be simple squamous epithelium. So we can say that the active thyroid gland has thicker epithelium than the hypoactive thyroid gland. As an endocrine organ, the thyroid will produce two hormones, namely thyroxine and thyrocalcitonin. Thyroxine will function to promote cell metabolism and cell growth, while thyrocalcitonin will lower the level of blood calcium. So when our blood calcium levels reaches high levels, the thyroid gland will produce thyrocalcitonin to reduce the level of blood calcium. The thyroid gland may malfunction. Either it is hyperfunction or it is hypofunctioning. When the thyroid gland is hypofunctioning, it will produce less thyroxine. Less thyroxine means less cellular growth and less cellular metabolism. When less cellular growth and metabolism happens in the cells of the central nervous system, this results in mental retardation. While in the musculoskeletal cells, if they experience low metabolism and low growth rates, it will result in growth retardation. So the effect of hypofunctioning thyroid glands will be growth and mental retardation. While in the other hand, in the other end of the spectrum, hyperfunctioning thyroid gland will promote fast metabolism and growth of the cells. If the cells in the body grow and metabolize very fast, there is no more energy reserve that can be stored. This causes the body to lose body weight and experience anorexia. And when the body experiences anorexia, superficially or from the outside, the body can look as though they appear just skin and bones. This causes the eye to pop out of the eye socket. The condition in which the eye pops out of the eye socket is known as exophthalmic goiter. Exo meaning outside and ophthalmic meaning eye. Let's move on to the histological slide of the thyroid gland. This is the histological slide of the active thyroid gland. How do we know this? Because the follicular cells right here is either simple columnar or simple cuboidal. It is thick. Now that we know that this is an active thyroid gland, we can move on to the histological anatomy. This whole circular structure right here is known as the thyroid follicle. The thyroid follicle will be lined on the periphery by follicular cells. So this whole round thing is thyroid follicle, and the cells surrounding the lumen on the periphery, this one right here, is the follicular cells. on the inside of the lumen of the thyroid follicle, this homogeneous structure is known as colloid. Colloid is a dissolver of the hormone thyroxine. This globules right here is thyroxine being produced and released into the colloid. So the colloid forms as some sort of emulsifier for the thyroxine hormone. Right here, this is thyroxine, and this pink structure is colloid, a liquid protein. As you can see, there are a number of thyroid follicles here and here. And in between these thyroid follicles, this black arrow points to the cells which are known as parafollicular cells. Let me change the color. This one is the parafollicular cells. Para meaning in between, and follicular meaning follicle, which means the cell in between the follicles is known as the parafollicular cells. Now, do you remember what the parafollicular cells will produce? Correct. The parafollicular cells will produce thyrocalcitonin, while the thyroid follicles will produce thyroxine. Right over here, let me draw an arrow. These are connective tissues because all structures in the body will be connected by one another by connective tissues. Okay, let's review and recap about the main structures of the thyroid gland. I'll erase this first. This whole round structure is known as the thyroid follicle. The thyroid follicle will be lined by follicular cells. These are follicular cells. And inside the lumen of the thyroid follicle, there is this homogeneous pink structure known as colloid. Colloid. And inside the colloid, there will be globules of thyroxine. This is thyroxine. In between the thyroid follicles, we will find cells known as parafollicular cells. Parafollicular cells. And parafollicular cells will function to produce thyrocalcitonin. That's all for the thyroid gland. Let's move on to our next organ from the integumentary system. But first of all, I'm gonna ask for a bit of time to erase all of this. Let's go. Now we have the integumentary of the fish. More specifically, this is a skin from the brook trout or Salvinia fontinalis. The fish skin is A for hydrodynamics. It aids in the fish's locomotion, and it also acts as a sensory organ. The fish skin produces a number of mucus. How do they do this? We will see in the histological slide. This mucus will help to reduce drag when the fish is moving through water. Because as you know, when you are moving through water, the molecules of water will be facing the other direction, and this causes drag. But fish needs to swim fast. Thus, they produce mucus, which forces the water molecules to not have a lot of friction. Fish skin also have lateral lines, which are sensory neuromasts, which detect chemical and barometric pressure. Macroscopically, the lateral line of the fish will appear as small dots lining the side of the fish. Okay, let's get straight on to the histological slide. Okay, let me annotate this. Similar to the skin of mammals or reptiles or other animals, the skin is divided into the epidermis, which is right here, and the dermis, which is right here, labeled D. But the fish has a very special skin structure. The epidermis of the skin of the fish, right here, in its stratum corneum, but I don't think the fish has a stratum corneum, is composed of stratified keratinized squamous epithelium, we can see this keratin layer right here, similar to that of other animals. Stratified squamous epithelium with keratin. But unlike any other animal in the world, the stratified squamous epithelium of the fish has goblet cells. These are the goblet cells. These dots, these facula musigens, are goblet cells. These goblet cells functions to produce mucus. And this mucus, as I mentioned before, will help to reduce the friction and reduce drag between the fish and the water. So this is one of the structures that make the fish skin so special compared to the skin of other animals. Second, we may also find these red structures, which are thickened keratin and a bit of mature bone tissue. These are known as scales. Now, one might wonder why the scales of the fish can be found in the upper part and the lower part of this histological preparation. I'll tell you that the scale of the fish is not layered just above, but the scale of the fish will be overlapping. So one will be above and one will be below, producing multi-layered armor. Now, as we can see here, one of the scales of the fish is located between the epidermis and the dermis, and the other one is embedded here straight in the dermis. Now let's move on to the normal histological anatomy of the skin of the fish. Let's erase all of this. Right. On the most upper part of the skin of the fish, we can find its epidermis, which, as other animals, are composed by stratified keratinized squamous epithelium. The only difference will be the epidermis of the fish will contain mucus-producing goblet cells. Moving on below, we can start to find a layer of collagen fiber. This is the stratum papillare of the dermis, or the projections of the dermis right here. So it means the dermis of the fish's stratum papillare will not be like that of the mammals, in which it is more messy. And right here, we can find the special structure, which are known as scales. And scales is a combination between keratin and mature bone tissue. Moving on, we can find the second layer of skin right here. Right here, from here and a bit from here, which are composed of collagen fibers. Right here, we can see this wavy extracellular matrix, extracellular matrix. These are thick, and these are collagen fibers, meaning these are the structures of the dermis of the fish. And like that of mammals, the collagen fibers has nucleus on the side. I almost forgot, but let's recap again. This is the epidermis of the fish. It contains goblet cells. These are the stratum papillare of the dermis of the fish, and it is formed by collagenous fibers. And this is the stratum reticulare of the fish, which is formed by also collagen fibers. But we can see, since this is sectioned longitudinally, we can see it more clearly. And these, the red structures formed by bone and by keratin, are scale. But right here is the one that I want to show you the most. This circular structure right here are sensory efferent neuromasts, known as lateral lines. So this opening, this lumen of the lateral line, will open directly to the water. So water will come in here, and the neuromasts, these neuromasts right here, will receive information regarding anything, regarding water pressure, electronic reception, and even the movement of other fish near it. And this is important because sometimes fish will swim in dirty water, and they cannot see the surroundings. So they rely on these lateral line pores. And down here below, we can see the fish's skeletal muscle. They have skeletal muscle bundles right here, surrounded by endomysium, and we can see the nucleus of the skeletal muscle fibers. That's all for the fish skin. Wait, let's erase all of this. And we move on to our last slide, which is thank you all for listening. I love you all. Don't forget to study. Histology is amazing.